Hello everyone, my name is Aryan and today I will discuss criteria of good estimator or properties of good estimators. Okay, so as we know that there may be a large number of real functions of sample values and which is called statistic that can be proposed as estimators of parameters. Okay, so to determine a best possible estimator out of a large number of statistics and impose suitable restriction on the class of estimators is one of the basic problem of estimation. Okay, so there are various properties that have been put forth as desirable for a statistic to be a good estimator. So there need not be a single set of criteria of estimation useful in all situation. Okay, so the important criteria that determine a good estimator are like unbiasedness, consistency, efficiency, sufficiency, completeness. Okay, so these are the criteria. On the basis of these criteria we can identify good estimator for estimation of population parameter. Okay, so out of these criteria today I will discuss about the sufficiency. So come to the sufficiency definition. I will explain you what is meant by sufficiency, and if we have any estimator then how we can identify given estimator is sufficient or not. Okay, so come to the next step. Okay, so firstly I will define what is mean by sufficiency of any particular estimator. Okay, so let x1 x2 up to xn be a random sample from probability mass function or probability density function fx theta, and theta belongs to parameter space. Okay, so let's suppose capital T be any function of sample values. That means T is equal to T of x1 x2 xn, which is used as an estimator for theta. Okay, so that means T is a statistic and we are using this statistic for estimation of parameter theta. That's why we call it estimator. Okay, so T is said to be sufficient for estimating the parameter theta if it contains all of the relevant information available in the sample about theta. Is it clear? That means T is said to be sufficient if T contains all relevant information available in the sample about theta. Okay, so this is the definition part of sufficiency or sufficient estimator. So this property of an estimator is called sufficiency. Is it clear? So this is first definition, but let's suppose if we have an estimator. Okay, so how we can verify that the given estimator is sufficient or not? So for this thing we have second approach is called conditional distribution approach. Okay, so now you can see here. Okay, so now you can see here, if T is equal to T function of x1 x2 xn is an estimator of a parameter theta based on a sample x1 x2 xn of size n from the population with density function fx theta, such that the conditional distribution of x1 x2 xn given T is independent of theta, then T is sufficient estimator for theta. Is it clear? That means let's suppose we have capital T is an estimator and x1 x2 xn are sample values, and if we are finding the conditional distribution of x1 x2 xn given capital T, and if the resultant is independent of theta, then T is sufficient estimator for theta. Okay, so this is the conditional distribution approach, by using this approach we can easily verify given estimator is sufficient or not. Okay, so as we know that we have two types of random variable. One is continuous random variable and second one is discrete random variable. So for discrete random variable, how we can use conditional distribution approach, and in case of the continuous random variable, how we can proceed the conditional distribution approach, I have mentioned here. So now you can see here, conditional distribution of x1 x2 xn given t is defined as, for discrete random variable, so probability of x1 x2 xn given capital T is equal to small t, so we can write it probability of x1 x2 xn intersection t upon probability of t is equal to small t by conditional probability formula. As we know that probability of A given B is equal to probability of A intersection B upon probability of B. Okay, so now we have left hand quantity x1 x2 xn given t, which is equal to probability of x1 x2 xn upon probability of t is equal to small t. So now you can see here, numerator is what? Numerator is joint density structure, because x1 x2 xn are IID, so all are in intersection form. So we can write it probability of x1 equal to small x1 into probability of x2 equal to small x2 and up to probability of xn equal to small xn, and denominator is probability of t is equal to small t. Okay, so t so t is said to be sufficient if and only if the ratio, that means equation number 1 is equal to h of x1 x2 xn. That means the ratio does not depend upon theta, and theta belongs to parameter space for every fixed value of estimator, which is based on x1 x2 xn. Is it clear? So this is the case for discrete random variable. Okay, so similarly we can proceed for continuous random variable, and now you can see here, for continuous random variable, conditional distribution of x1 x2 xn given t is defined as f of x1 x2 xn given t is equal to joint density upon density of sufficient statistic. Okay, so where fx theta be the PDF of x, where theta belongs to parameter space, and ft t comma theta be the PDF of t, and t is sufficient statistic. Okay, so t is sufficient for theta if and only if equation number 2 independent of theta. Is it clear? Okay, so that means we have procedure for discrete random variable and continuous random variable, and we can apply for any given particular problem. So now come to the one problem based on the discrete random variable, and to clear that how we can apply these steps. Okay, so come to the problem. Okay, so in this problem, now you can see here, let x follow Bernoulli distribution with parameter 1 comma theta. Let x1 x2 xn constitute a random sample from the Bernoulli distribution, then so that t is equal to summation of xi is sufficient for theta. Okay, so this is the question part, and come to the solution for part. So here we will follow the same procedure as I have mentioned in previous step. So what we have here, x follow Bernoulli distribution, and then capital T is what? Capital T is summation of xi. So if x1 x2 xn follow Bernoulli, so we know that summation of xi, x1 plus x2 xn will follow binomial distribution with parameter n comma theta. Is it clear? And we know that the probability mass function of binomial distribution, let t is equal to k, then probability of t is equal to k can be defined as nck theta to power k 1 minus theta to power n minus k. As we know that the standard form of binomial distribution is what? ncx p to power x and 1 minus p to power n minus x. So in place of x what we have here? K, and in place of p what we have here? Theta. Okay, so using definition criteria, that means conditional distribution approach. Okay, so the conditional distribution of x1 x2 xn given t is defined as left hand quantity is probability of x1 x2 xn conditioning with t, and we can write the right hand quantity is probability of x1 intersection x2 up to intersection xn intersection t, upon denominator part is probability of t is equal to k, and we know that the numerator quantity is joint density of x1 x2 xn. So now we can rewrite numerator part. Okay, so now the numerator part can be written as the x1 intersection x2 up to intersection t. Okay, and denominator part is probability of t equal to k, and we know that the numerator is what? Joint density of x1 x2 xn. So now putting the value of probability of x1 equal to x1, probability of x2 equal to x2, and probability of xn equal to xn, what we get? Now you can see here theta to power summation of xi 1 minus theta to power n minus summation of xi, because probability of x1 is equal to small x1 is what? Theta to power what? Theta to power x1 and 1 minus theta to power what? 1 minus x1. Okay, by the Bernoulli density function. Okay, and we have n terms, so that's why we are comprising all term and we get this resultant. And denominator part is probability of, denominator part is what? Probability of t is equal to k. Okay, so now you can see here we know that distribution of probability t is equal to k is what? Binomial distribution, and probability mass function of binomial distribution is nck theta to power k 1 minus theta to power n minus k. So now after simplifying this, because summation of xi is what? Capital T, and we are taking capital T is equal to k, so that's why in place of summation of xi what we are putting here? K. So after simplifying, that means this term cancel out, this term cancel out. What is the resultant? 1 upon nck. Is it clear? And in conditional distribution approach, what we have? We know that if the conditional distribution of x1 x2 xn given suggested estimator is independent of parameter theta, then suggested estimator is called sufficient estimator. Okay, so now hence prove that t is sufficient estimator for theta, or t is sufficient for theta in case of Bernoulli distribution. Okay, so thank you so much to everyone for watching this video, and in my next lecture again I will join you with a few more problem based on good criteria or the criteria of good estimator. So thank you guys.